All
All
right,
right, so
so I'm
I'm
gonna
gonna
do
do
module
module
five
five
here
here
as a
as a student,
student,
um,
just
just
to
to
help
help
you
you
guys
guys
out.
out.
So
So
here,
here,
module
module
five,
five,
question
question
one,
one,
match
match
the
the
condensed
condensed
structural
structural
formula
formula
with
with
the
the
formula
formula
on
on
the
the
left.
left.
So we have, so here in our first one, oops. All right, so we have COOH. All right. So a carbon, carbon, and then a COOH, which represents a carboxyl group. So I see that as being this one right here, right? So we have one carbon, two carbon, and then the carboxyl group. Here I see a carbon, an oxygen, and then two carbons, all right, which happens to match here. We have a CH3, an oxygen, a CH2, a CH3. Here we have one, two, three, four carbons and then an OH group. Ironically, these all just happen to be right across. So we have one, two, three, four carbons and then an OH group. And finally, two carbons. And then that last one has an oxygen and an explicit hydrogen on it. So right across. So how do you get them? There we go. So I'm going to go ahead and submit just so you guys get a little satisfaction. All right. So then these questions are similar if you get one of these. Again, your question base is going to be different, but hopefully this helps. All right. So these blues are carbons, oxygens are reds, and then the um, whites are the hydrogens. Here, you can't tell if they're double bonded, but the position of the oxygens should help you determine which is which. All right. Question two, naming alkanes. All right, so alkane is all single bonds, right? And then ends in ane. All right. So I know my suffix, I know my functional group. My next step is to number my carbon. So I have one, two, three, four. I can number it left to right or right to left, but I want to make it the I want to make the branches the lowest possible carbon. So right now I have one branch on carbon two, and if I was to flip that numbering scheme, the carbon would end on three. So I'm going to keep it the way it is. So I know it ends in ane, and then I have four carbons in the parent chain. So bute. So butane takes care of this whole parent chain. Next, I have to take care of the branches. So I tell the audience what carbon number of the parent chain that branch is coming off of, and then I tell the audience what the branch is. So one carbon branch, like the one we see here, is methyl. All right. So it's 2-methylbutane. All right. I'm going to clear this and I'm going to type it in. 2-methylbutane. So hyphens between the numbers and words. And here we go. The feedback here is horrible. Like here's an example where yes, butane is the parent chain, but it doesn't talk about the branches in the feedback here. So if you're like, oh, I put butane, just remember that the feedback is only talking about the parent chain. Let's see. Let's do this example. So you want to manipulate these by holding down your mouse pad and moving them in order so that we can get a good view, right? So I'm gonna kind of put it right here because this is how I see it. I see a parent chain here, a branch, and then another branch here. All right. So if I come off to the side, I see this. All right. So all single bonds, so we're still an alkane ending in ane. So my next step is to number 1, 2, 3, 4, 5. So the main chain is pentane. All right. Now I gotta take care of the branches. So I have 3 branches here, all 1 carbon branches, so all methyl branches. So when you have multiple of the same branch, you put a di or even a tri. So in this case, it's going to be trimethyl, which we didn't see a lot of examples of. All right, so this is going to be trimethyl. So I put that before the pentane. And then next, I need to tell the audience where they are. So we have one coming off of carbon 2. We have a second one coming off of carbon 2, so I'm going to put comma 2. And then we have one coming off of carbon 4. So I'm going to put comma carbon 4 hyphen trimethylpentane. All right. So I'll clear this and type it in just so we can see the beautiful green trimethylpentane. Beautiful. All right. This one was about cyclohexanes. And you gotta watch I think I took out the bad ones, but so you wanna match the models with what is shown up here. So here, again, I'm gonna orient this to, oh no. I'm gonna orient this so that way I can see it. So what I see here is a 4 carbon ring and then a branch, kind of looking like this. All right. So definitely matches that. And if the carbons were explicitly drawn out, it matches that guy. There we go. See what else? All right, similar. So what I see again is basically square or 4 carbon ring with a branch coming off one of the points and then uh, another branch coming off the point right next to it. So these two is what I see. Yep. All right. Classifying hydrocarbons. All right, so again, this was something we talked about kind of briefly. So, oh, wait, this isn't the question I thought it was. Okay, so alkane, all single bonds. All single. Alkene, a double bond. I drew that up and down or side to side. Alkane, triple bond, so 3. And an arene is a ring. All right. So right here, I see all single bonds. So alkane. Here I do see double bonds, but they are in rings, so I'm gonna choose arene. Here I see 3 bonds, triple bond, alkane. And again, I do see double bonds, but they're in those rings, so it's an arene. There we go. All right, I'm not gonna do a second one of that. I'm gonna focus in here on the naming. All right, so alkene. All right, so alkenes, their characteristic is this double bond. So this is the molecule I see, which is kind of a hard one. I'm glad I got this as an example. All right, so I know it's an alkene for a couple reasons. It has a double bond, and because, I know I'm in the alkene part of naming. So it's going to end in E and E. Next step is to number the longest chain. So I'm going to number 1, 2, 3, 4. So this is a butene. All right. My next step, when I have functional groups that aren't alkanes, is to tell the audience where that functional group is. So our functional group here, the double bond spans from carbons 2 to 3, but we only need to tell the audience the lowest. So we'd say 2-butene. All right. And so as I have it written, that covers everything that's I just circled. What we do still have to take care of is these branches. They're one carbon branches, so they're methyl branches, and there's two of them. So it's going to be a dimethyl. All right, so that's going to come out in front of this two. We still have to put another hyphen to separate those numbers and words. All right, so I know I have two methyl groups. Now I need to tell the audience where they are. So they're off of carbon 2 and 3. So 2,3 dimethyl 2 butene. All right, so 2,3 dimethyl 2 butene. Figure this. 2,3 dimethyl. All right. Here's another butene. Let's see. Yeah, let's do this one. All right. So we're still in alkenes, right? I know it has an ending E and E. I see that double bond right here. I want to number my carbon and I want to put that double bond at the lowest possible position. But I see that this is a symmetrical molecule, so it doesn't matter if I um, number left to right or right to left, it's always gonna span between carbons 3 and 4. So there's 6 carbons in the main chain, which is hex, and then ene because there's a double bond. Then I need to tell the audience where that double bond is. It spans from 3 to 4, but I only need to tell the audience the lowest of those two numbers, so I would say 3-hexene. All right, so that covers the parent chain. Now I need to take care of this branch here. So it's a 1 carbon branch, so it's a methyl. So methyl, and then I need to tell the audience what number carbon it's coming off of, and it's coming off of carbon 4. So 4 methyl 3 hexene. Oh no. What is it not like? Oh, okay. I think I figured it out. So because it's a symmetrical molecule, and I can number left to right or right to left, and either way it's going to work, I should then also prioritize the branch. So 1, 2, 3, 4, 5, 6. That still puts the hexene bond at 3, and it makes that branch at a lower position. So let's try that. There. I'm glad we had that. All right. Alkanes. So a characteristic of alkanes is that they have the triple bond and they end in Y-N-E. This is kind of simple. Let me see what else we got. Oh yeah, let's do these models. All right. So I'm gonna just kind of adjust it here. This is hard. All right, so I see the parent chain here and then a branch here. So I see 1, 2, 3, carbon, branch. All right, so I see 1, 2. Oh, there's another one. 1, 2, 3, 4, 5. Ignore my drawing over here. I'm getting myself confused. Okay, so 1, 2, 3, 4, 5. I put the triple bond at carbon 1 because I want it to be at the lowest. And then we also got a branch coming off of carbon 4. So I know it ends in Y-N-E because of the triple bond. 5 carbons in the main chain is pent. And then 1 to tell the audience where that bond is. And then we have this 1 carbon branch here, which is a methyl branch. And it's coming off of carbon 4. So 4 methyl 1 pentyne. There we go. All right, let's look at this one. Ooh, all right. So I see our main chain here, and then I see a 2 carbon branch here, right? The branch is continuous. It really goes that other direction, but I think it looks prettier if I draw it like this. Oops. All right, so again, I want my triple bond to be at the lowest possible position, so I put it over here to the left at carbon 1. It looks like I have a pentyne again. All right, tell the audience that it's at carbon 1. And then this branch. So we've only been seeing methyl branches in this video so far, but this is a 2-carbon branch. It's continuous, boom, boom. So this is an ethyl branch. So ethyl, but same process. I have to tell the audience that it's at carbon 3. So 3 ethyl, 1 pentane. There we go. All right, there's a lowdown of module 5.